Alright, so right now we're going to talk about solving quadratic inequalities. Should be fairly simple, I think. So every once in a while we come across times where when we solve a problem, we don't want a very specific number. We want to look at an interval or a range of numbers. So we talk about inequalities as opposed to equations, and these are just a couple different examples that I could come up with. So when we do solve these problems, in a couple minutes here, our answers are going to be either inequalities, like x is greater than 5 or something, but we're going to actually put it in interval notation, so hopefully you remember your interval notation. So here are the 3 basic steps that we're going to be following when we solve a quadratic inequality. The first thing that we want to do is to factor out your quadratic expression so that you can get your x-intercepts. Those are the places where your graph is going to cross the x-axis, right? The next thing you're going to do is look at the a. So whether you factored that out when you did step 1 or you just look at the original inequality to see what a is. And the only thing that we really care about a is it positive or negative? Meaning, is our graph going to open up or open down? We're not actually going to graph these things accurately. We're just going to randomly sketch what our parabola would look like passing through the x-intercepts and knowing that it opens up or down. After that, then we are going to look to see where the graph is positive or negative. Basically, where are the y values that are positive and where are the y values that are negative. And depending on what our inequality is, that will tell us which intervals or interval is the solution. So this seems very vague right now, but when we apply it to a problem, you'll see how these steps work out. All right, so here's just a quick reminder of interval notation. If you've forgotten, this can be useful for you, or maybe we've done it so often that you already understand this all very well. All right, so there you go. All right, so to start us off, we have x squared minus 3x minus 10 is greater than 0. So the first step is to factor our quadratic expression, and we're looking for our x-intercepts. So I did set this equal to 0 since we want to solve for the x-intercepts. So they come out to be -2 and +5. Now over here, I am doing kind of an informal graph. It doesn't need to be accurate or on graph paper, and you don't necessarily need to do this if you really understand what's happening here. These 2 places is where the graph is going to cross the x-axis. So the next thing that we want to do is look at a, and a is 1, which is positive. I don't really care if it's 2 or 5 or whatever. I just want to know that it's positive so that I know that this graph is going to open up. And if it opens up and it has to pass through -2 and +5, I know it's going to start up over here, cross the x-axis, go below down here, cross the x-axis again, and go back up. So something like this. And I know I missed that a little bit over there, so forgive me. Okay, so what we're going to do to analyze this and to solve our inequality, I want you to think of it as y is equal to x squared minus 3x minus 10. And so think that, this is the graph of y equals that whole thing. And we want to find where y is positive. Y is greater than 0. Because remember this right here, we can substitute in for y. So what that's telling us is if we look at our graph, we want to look at all the places where the red parabola there is positive y values. So really, this x-axis is the deciding factor, or the dividing line between the positive and the negative. So you can kind of think about up here is all the positive, right? And down here is all the negative. Well, on top of that, the x-intercepts also break it up into 3 different intervals. So we have the interval that's to the left of -2, we have the interval that's to the right of 5, and then we have the interval that's in between -2 and +5. And if you notice, the interval that's to the left of -2, that has all these positive y values, right? And then also over here, the interval that's to the right of 5 has all the positive y values. And then the interval between -2 and 5, these are where all the y values are negative. They're all below the x-axis. So to answer our question, says the equation yields positive y values when, well, that would be when x is less than -2 or when x is greater than 5. So we have these two inequalities that would be where you get positive y values. And then it yields negative values when it's in between -2 and 5. And we don't have equal signs with these because there was no equal sign there. So our actual answer, because our problem is asking for all the values that are greater than 0, we want the positive y values. So that means of these two, the one that gives you the positive y values is this one. So it's here's the positive and there's the positive. So putting this right here, these inequalities into interval notation, hopefully you remember from the last slide, would be from -infinity to -2 with the union of 5 to positive infinity. And we have soft parentheses right here with the -2 and 5 because there's no equal sign. We don't include those values. Okay, so this may seem a little uncomfortable at first, but let's try another one and you'll see it's very repetitive and gets to be the same thing over and over again. You'll see patterns. Okay, so next one. We have -x² plus 4x plus 12 is greater than or equal to 0. And the first thing that I did here is I just divided through by a negative. And when you divide through by a negative, remember that this inequality symbol needs to get flipped. Okay? So now I have a positive a. Not that you have to do that, because you could work with this still with the negative, but I think it's easier to just always have a be positive, and then they all look the same. But it's up to you. Okay, so the next thing that we would do is find the x-intercept. So I factor, and that gets me -2 and +6. Notice over here that I didn't even put the y-axis because I really don't care about it. All I care about are the x-intercepts. And then I'm going to draw in my parabola, and I know it opens up because I made a positive. So it looks like this. Okay. I'm not going to draw in my vertical lines, but once again we can see that at -2, to the left of it, we have positive y values. And then to the right of 6, you have positive y values. And then in between -2 and -6, we have the negative values. So now what I do is I go over here, look at this, not the original one, this one is the one that we graphed because we have a is positive. We want it to be less than or equal to 0. So this means that now we are looking for the negative y values. So that's everything that's underneath the x-axis. So this will be the interval between -2 and +6, and we do get to include those values so that we're going to have the hard brackets around them. Okay, so that's it. Fairly simple. There are a couple exceptions to the rule, of course, that I want you guys to think about. What if the parabola doesn't have x-intercepts, so it's floating above the x-axis maybe? What would happen then? Or what if this quadratic expression is a perfect square trinomial and there's only one x-intercept? What would that mean? Is it opening up, opening down, whatever? So just think about those different unique situations, and if you need to graph it out just like this, it doesn't have to be accurate or on graph paper. Okay, that's all.